Hello, my name is Fasim Japar. I am student DHSFI University and doing mechanical engineering. Today we are going to learn numerical solution of ordinary differential equations by using Picards method. The main formula of Picards method can be seen here, which is y1 is equals to y0 plus integral of function of x and y0 by dx. This is basically our first approximation. We're gonna make some approximation depending upon the position we want in our answer. So for the second approximation, we will do y2 is equals to y0 plus integral of x, integral of function of x uh, and y1 by dx. The limits here are x and x0, similarly which were in the first case. So we're gonna do integral approximation depending upon the position. So our last approximation will be yn equals to y0 plus integral function of x and yn minus 1 of dx. The limits are still same x and x0. The thing which you have to note here is that the approximations are almost same, but the only thing changing are y0, y1 and yn minus 1. You're gonna understand what these things really are when we start solving an example. So we are considering a question here. It says that dy by dx is equals to 1 plus xy, which is a ordinary differential equation, and we are given that y of 0 is equals to 1. So we have to calculate y of 0.1 using Picards method. First of all, we will extract our values of x0 and y0. As you can see, y of 0 is equals to 1, where x0 is basically the element in our bracket, which is 0. So our x0 is equal to 0 and our y0 is the element on the right hand side of the given equation, which is 1. So x0 is equal to 0 and y0 is equal to 1. And we will make this differential equation as a function of x and y. So we will first do the first approximation, and its formula is given here. So our y1 will be y0, which is 1, plus function of x0 plus x0 and y0 divided by dx. So for our function of x0 y1 was 1 plus xy, which is our differential equation. We have put this equation here. The thing to notice is that instead of 1 plus xy, we have put 1 plus x y0, because we use y0 in our first approximation. We're gonna solve it. As you can see, first we put the value of y0, which is 1, and then we're gonna integrate it, so by dx. So our due to our parameter, it becomes x plus x square upon 2. It's basically a simple integration. So we have our values, which is y1. We have our value of first approximation, which is y1 is equals to 1 plus x square upon 2. Now we're gonna do our second approximation. We will go through the same method. And yeah, one more thing. We're gonna, as I have told you earlier, that we're gonna keep making approximation depends upon our position that we want in our answer, but the thing is that you're gonna have to at least evaluate two approximation which we have did that, which are y1 and y2. So for our second approximation, you can see that uh, instead of now y0 we have put y1, and that's and this is only the value of our first approximation. So again, I'm gonna put values y0 equals to 1, and our function, which is 1 plus x y, and now it will become 1 plus xy 1. We're first put value of y0 we just found earlier, which is the first approximation. Then we gonna integrate this. So we have our y2, which is equals to 1 plus x square 2 plus x cubed upon 3 plus x raised to the power 4 upon 8. uh, uh, we will go through the same procedure to find our third approximation, which I have written here. You can check that by solving it by yourself. So I think that will do the work, considering our position that we want in our answer. Now we just have to put these value to get our real answer. So the thing we will do is that in question they ask to find y of 0.1. So so in our third approximation we're gonna put 0.1 instead of x. So y of 0.1 is equals to 1, and as you can see I have put 0.1 instead of x everywhere in the equation. Now we have no unknown here, so we're gonna calculate the value of y of 0.1, which comes out to be 1.10534. That's all for Picards method. Thank you.